Rational graph example 3. Y, let's say we have a y equal to x plus 1. Denominator is x squared minus 9. So first what do? We factorize the denominator. We take out the x. So here we will get so you can write as x squared minus 3 squared. So in other words, means is you get x minus 3, you get x plus 3. Alright, from here we proceed to find the domain. So the first information that we can find is domain. So what do? We set the denominator, put it cannot be 0. So x minus 3, x plus 3 cannot be 0. So x cannot be 3, x cannot be minus 3. Alright, so means the graph that you draw later, we cannot have any x value which are 3 and minus 3. Right, the next information we'll find will be your interval. So we go and intercept. We go and find the x-intercept. So y equal to 0. So 0. So x plus 1. So here is x minus 3. Here is x plus 3. So as you can see, the 0 will multiply with this whole thing. So we get 0 equal to x plus 1. So x we get is minus 1. Okay, so put in the graph there, minus 1. Alright, so we have a minus 1 here. There's only x-intercept, so proceed to find the next one, which is your y-intercept. So y-intercept, we put the x equal to 0, so 0 minus 3, 0 plus 3. 1 here, so below will be your minus 9. So the value is 0 minus 1 over 9. So minus 1 over 9 is somewhere here. So this is your minus 1 over 9. Alright. And next we'll go and find out the VA, vertical asymptotes. So the third information we will find is known as your vertical asymptotes. So to find vertical asymptote, that's why I put it beside the domain. So basically it's quite similar the step here. The only thing that changed is that you set to 0. X minus 3, x plus 3 equals 0, x equal to 3, x equal to minus 3. So label it. So here we have one vertical asymptote, x equal to minus 3. Another one is here, x equal to 3. Okay. The information number 4, we're going to find out whether you have a HA or whether you have an OA. And we need to compare the degree. So as you can see that the degree of the numerator, which is 1, is less than the degree of the denominator. Denominator is this one, and you can see it's 2. So it's 1 versus 2. That's why I say degree of numerator is less than the degree of denominator. So when this happens, HA will be exist, OA does not exist. So the equation of the horizontal asymptote is y equal to 0. So this one already fixed. So we will just draw a horizontal asymptote somewhere here, so which is y equal to 0. Okay, so before we can complete the graph, we have to do one more last step, which is the intervals analysis. So I call it intervals analysis. So this one you have to get the x value first. So how do we get the x value? You set on top becomes 0. We'll get the value will be minus 1. You set below the denominator equal to 0, we get 2x value. We get 3, we get minus 3. Then what do you do next? You draw a straight line. Put from the small to a big value. So minus 3 come first, followed by minus 1, then followed by 3. Ending is infinity. So you will see that you will have how many intervals? So in this case, we have 1, 2, 3, 4. So we have 4 intervals. So we need to check the y value, whether it's plus or minus. So we have to suggest a number between these intervals. So the first intervals, pick any number within here, within this range. So I'll just pick minus 10. Second one, you can pick minus 2. Second one, third one, you can pick 2. Here you can pick 10. So what do you do next? First interval, we do one by one. Minus 10, put it on top. Minus 10 plus 1, so we get negative 9. So it's a negative. Minus 10, this part will be negative. This part will be negative. So we get positive. And then negative divided by positive, so I just call it we'll get ne. Alright, the second one, minus 2 on top, negative. Below, here is negative, here is positive. So ne, we get po. So plus divided by minus, we will get, sorry, let me check again. Minus 2 on top is negative, yes, correct. Okay, here is negative 2 is negative, so this part is positive. So, sorry, it shouldn't be plus. You check again. This is negative, this is positive. Ne, we get ne. So, ne divide, we get plus. Okay, 2 now. The third intervals, put it on top 2. 2 is plus. Below, negative, positive. So, negative plus divided by negative, we get negative. The third one is put in the 10. 10 here. So, overall is all plus. Plus, plus, plus. So, this one show you whether it's above or below x-axis. Negative show that it's below. Plus show that it's above x-axis. So now we're going to complete the graph here. Okay, first intervals minus infinity to minus 3, meaning this part. There's something negative, something below the x-axis, so means somewhere here. So two asymptotes intercept, so we'll draw something like this. Second intervals is minus 3 to negative 1. You see a plus, so something above, so means must be here. Nothing here, so it's above here. And there's an intercept, you can see minus 1, so that's really will be something like this. And negative 1 to 3, you see negative, so means these intervals, there will be a graph below here, which is true because this one will join with this point. Once they join, the graph is actually approaching the asymptotes. Continue here. And 3 to plus infinity means this part of the graph. You see a plus sign, so means there will be something above here. So asymptotes here, draw a line, continue here. Yes. So this will be your graph of your what do you call that, the rational functions. And one important things to take note here is that you see that this paragraph, that the graph actually crosses the horizontal asymptotes, so it's possible. So for any horizontal possible, sometimes a graph may cross over the horizontal asymptotes, but for vertical asymptotes, a graph can no way cross over a vertical asymptotes. So this part is actually correct. You will cross over the y equal to 0, which is the horizontal asymptotes. So I'll see you in the next video, right? Thank you.